Well, hello everyone and welcome to Emerald Hill Skies. My name is Doug and I'm speaking to you tonight from the outskirts of Louisville, Kentucky. We're glad you're here. It's a little bit of a hair-raising start tonight. OBS, the streaming software we use to be able to cast these images to the internet, has done a really great upgrade, but when they did, it rendered a lot of our programs incompatible. We had to do a lot of reconnoitering to get everything started again, so I'm hoping that everything's going to work. Let me just check out here and make sure we are live here, and I want to check that audio to make sure that it's live. Okay, I think that's working. So we'll get through this one way or the other. Once again, welcome. We're going to start and just dive right in tonight. Let's see. We have our new software here, Deep Sky Planner 8. And let's get going with the first object, and then we'll be able to talk some more about what we're doing tonight. So the first object is NGC 4143. And let's try to slew to that. Let's see. You know, the telescope we're using is a RASA 11. You can look down in the description of this video and see a lot of the equipment that we're using. This RASA 11 is sitting on top of a Pier-Tech Adjustable-Height frame, and it's all located in a Pier-Tech Tele-Station 2 observatory. And let's see, we're going to try to do a bit of a plate solve here, which takes a picture of the night sky, compares it to through the telescope live, compares it to the images it expected to see, and if those images are a little bit off, then the mount will attempt to synchronize those images and bring them together. We were off about 2.21 degrees. Like I've said before, if you've been on the channel, that's not uncommon on our first target, because the mount is just getting started. We don't do any kind of, if you're familiar with astronomy and telescope mounts, some people use a hand paddle and a 3-star alignment. We don't do any of that. We just slew straight to where we thought the first target would be, and then we use this plate solving miracle to be able to get things aligned. And as we go to each target, those alignments improve, we hope and trust. Now tonight's going to be a unique night because we do have a 93% moon, and you know, when we have a 93% moon, it is a bit of an adventure. But our approach here at Emerald Hill Skies is we don't stop observing just because there's a moon out. We think that would be kind of cowering, you know, in the moonlight, so to speak. We go ahead and try to observe and do the best we can. Besides, we have plenty of light pollution anyway, and it's really crazy to have to cancel just because there's a bit of a moon out. So what happens is, though, it does change the ability of our telescope to be able to bring in those faint objects, and we just are honest with people and we just say, hey, that's the way life is, and we just roll with it. Tonight, in addition then to that moonlight, we're going to have a little bit of city light pollution too. And these objects sometimes are very low on the horizon. This one's at about 43, 46. It's about 17 degrees above the horizon right now, which isn't terrible, but with our Louisville light pollution the way it is, it can definitely be terrible and look that way. So what we're going to do is we're going to try to let's see. I'm going to try to switch now to bring this in. One of the things that happened is our upgrade to OBS streaming made it impossible for me to use the switcher here that I normally use. For some reason, their plugin didn't install correctly. So while this is stacking a few frames, and what we're doing now is live stacking, and it just mounts one frame on top of another, we're going to put the name up here, and this is again NGC 4346. Okay, and we'll also put it in the title, NGC 4346, a galaxy in 4346, galaxy in Canes Venatici, Canes Venatici, something like that. Just going from memory there. Okay, let's come back here. Now, while that's live stacking for another minute, let's come over and see what's been happening here on the stream. Azray, welcome from Arizona. Glad you're here tonight. Oh, we want to put you back on the screen. There we go. Let's see, Mike, good to have you from Georgia. We're glad you're not late, by the way. Pier-Tech, Vito, good to have you. Larry Fraley, welcome, brother. You're in Washington tonight, not in your normal habitat of Peoria, Arizona, Greater Phoenix. Dennis, good to have you here from Smoky, Colorado. Sorry about the fires out there. And Kimberly, welcome to you from Venus, Florida. Midnight Silver Run, glad to have you. The moon is amazing tonight. You know, I'm not going to say a lot about it because, you know, a lot of times we kind of wish it wasn't so bright on a night like tonight, but we just put up with it, don't we? That's the way life has to be for us in astro imaging, astrophotography, electronically assisted astronomy, all that stuff. So what we're doing here is we're looking at NGC 4346. And if you wouldn't mind, if you're observing tonight with us, we have about a dozen with us so far, would you be kind enough to put the place where you're observing from, if you haven't done so already? We're gonna locate this little galaxy here, and look, it's right there in the middle, and it's a very tiny galaxy. Right there in the middle. Let's zoom in a little bit closer. You can start to see it kind of form up. And clear skies in northern Illinois. Good to have you here, Midnight Silver Run. I'm going to look up now NGC 4346. It's on page 181 in the guidebook that we use as we're observing these Herschel 400 objects. And the guidebook we use is Stephen James O'Meara's book. It's called the Herschel 400. See if I can get it on the screen here. The Herschel 400 Observing Guide, Steve O'Meara. And on page 181, he writes about NGC 4346. It is a small but bright lenticular galaxy. A lenticular galaxy is kind of like rectangular or oblong. We can't really see a lot of the structure to see if it's spiral, so we just call it lenticular. Its core is very condensed, which will help users of small telescopes to see it well. It's small and somewhat round. I guess you could say that core is round, isn't it? With averted vision, the core appears highly condensed and relatively bright and obvious. We're starting to see that bright core there, very tiny right in the middle. It's very small and star-like. I bet when you first saw this, you might have thought it was a star. Surrounded by a tight inner halo of light, which is at the core of a tapered ellipse of extremely faint light, oriented roughly east to west. So this is NGC 4346, a lenticular galaxy. And what we try to do with each object is we go over here, 4346, and we, let's see, I'm going to pull and do a quick observation. We add an observation, and let's see, we're going to add our session tonight, which is on 9/7, and let's take it all the way to 9/8 till we get to about maybe 1 a.m. 1 a.m. Okay, and we're going to go 93% moonlit. That'll start our session, and that'll stay with us all night. All of our equipment looks good. It's already there. And in our notes, we're going to say we could make we could easily make out the bright star-like inner core around with the oblong lenticular galaxy around it. Okay. Now once we've added that observation, 4346 will disappear from our list. And that's because we have this list filtered tonight so that it's only showing the objects we have not observed. One last thing I'd like to do is play a little bit more with these mids and see if we can get a little bit more of that structure of that lenticular galaxy. Boy, maybe we can reduce the sky glow. Boy, then that gets rid of the entire lenticular structure, doesn't it? So we're going to have to be right there, and then when we bring up our mids, it brings up all the sky glow with it. So this is just right at the edge of observing in the time that we have. But when we zoom in with our opticals, with our digital zoom, we can definitely see a lot more fuzz around it. I'm going to increase the sky glow a little bit because that'll let us see a little more of the structure glow, I hope. This is a tough object to bring in just 8 minutes of observing, but that's the way the Herschel list is. Some of these objects are very faint. That's why it's you know, a little bit more advanced than the Messier list, a little bit more advanced than the Caldwell list. It's like a 101, 201, 301. This is a 301 level object here, but you can definitely make out the core of this galaxy. Let's see what you all are saying about it tonight. See if anybody's adding anything. Asray, clouds in Glendale, Pier-Tech, moonlit skies at Pier-Tech headquarters in Bartlett, Illinois. Jupiter is at 20 degrees up from the eastern horizon. Dennis, can your RASA pick up M106 in your frame? You know, we weren't looking for M106. It might be there, though. Let's back out to full frame here. And then we'll have to back off with our mids a little bit. We're getting a lot of the sky glow from Louisville there on the left. I'm not seeing M106 in that frame. Let's go over to our planetarium software and zoom in here and see where M106 would be. It does not look like it's in the frame of our RASA tonight, sadly. So not in the same frame, sorry to say. Dane, good to have you here from Minnesota. Stu, welcome to New Zealand, from New Zealand. I hope you can, kia ora, yeah, I hope you can help us with some of the information on these objects, Stu. That would be great. All right, well, we're going to go back in at a tighter zoom. I think we were somewhere around there. And pull up our mids a little more. Get as much structure of that as we can. Not very much there. And then save it exactly as seen. All right, so that's our NGC 4346. Now we're going to switch our sequencer to next target. And our next object that we're going to look at is NGC 4143. So we're going to slew to that. And that object is at 11 degrees above the horizon. Boy, these are all really low, aren't they? 4143. Let's back off to full frame. There you can see a little bit of how close we are to the trees down there at the bottom. This is going to have to be a quick observing of NGC 4143. Let's do a quick plate solve. We're going to lose this very quickly, aren't we? I think I might see it there in the middle. But let's do the plate solve so that we make sure we're right spot on. Boy, that tree is coming up quickly, isn't it? Plate solve said we were just 600ths of a degree off. So let's quickly go into our imaging. Whoops, it might have still been settling there, but with any luck, the first image will come in and it will have been settled. This is, by the way, NGC is it 524? Is that where we went? No, I forget what we did. NGC 524, I think it was. And we'll put that in the title, kind of hurrying here. NGC 524. And let's do a quick. Wow, look how quickly that image is disintegrating there. Lots of trees, huh? Right into the trees. But we can spot that object right there in the middle. It's also a galaxy, but I don't think this object is gonna come through much because of all the trees. Sad to say. Let's try bringing down our reds a bit. Wow, what a mess. Right there in the middle is where this object is located. Way down in the Louisville light glow. That's not a very pretty picture of it. It is being lost in the haze there, isn't it? 524. We'll add an observation here. This object was nearly lost in trees when we arrived. Just could make out the bright inner core. How about that? While that's disappearing beyond the trees, oh, you guys are not on the screen, are you? While that's disappearing behind the trees, oh my goodness, Pier-Tech, $19.99 for that super chat gift that you made. You said some dollars for your equipment upkeep. Azra, so the moon is out and bright. We're seeing title screen. Yeah, you should be back now. You're just seeing this disappear behind the trees. NGC. Boy, I don't know if let's come back and see this object another night. That's just not a good enough image of it. And let's start again here. Let's go to this one that's 15 degrees above the horizon. That's 4085. Let's stick to maybe 15 degrees and up. How about that? Not do any more of these 11-degree targets. At 15 degrees above the horizon, let's head to that one. 50 degrees, and that's 4085. I think I'm going to take this off of auto run. 4085. That's a galaxy in Ursa Major. 4085. Let's go back out to full screen. And let's do that plate solve again just to be sure. Boy, thank you again, Vito, for that amazing gift, $19.99. By the way, I want to tell you guys that we just finally made peace with YouTube literally yesterday morning. They accepted all the details we had filed, and they liked the way we had connected with the account finally, and they finally sent a transfer, they said, yesterday morning. And I wanted to tell you guys, because many of you guys are the ones who have given these super chats, and you've also participated in these videos, and when you do that, that is also creating plate solved, and the difference was 0.11 degrees. So this one was worth it. I want to tell you that YouTube just sent a gift of $463. All of the gifts that you guys have given from the very beginning to now, since I guess it was that big night that we did that meteor storm. That's the night that we started being able to actually do whatever you'd call these super chats, and be able to have people make gifts like this. All that started that night of that big meteor storm. So far, as of yesterday morning, $463 to come in now. Now, Vito just gave $19.99, so that's in addition to that $463. And as I've promised, every single penny of that money that comes in, we're going to donate to help a Ukrainian family that's having a hard time behind enemy lines in Ukraine. And we happen to have, as of yesterday morning, 2 families that we'd like to help. So we'll just try to split this basically between the 2 of them. Our hope is that this will help them buy some potatoes or some canned goods to be able to survive the conflict that they're in, and be able to make it through this cold winter. When you stop and think about, it's going to be quite an adventure for them being in this cold winter, and we want to try to make this as helpful to them as possible. So that's what we're going to do with that money, $463. Thank you guys for pitching that in so far. Every dime that was given so far is going to go toward those two Ukrainian families behind enemy lines in Ukraine, where that conflict, where the war is going on. But starting tonight, in other words, starting with your gift, Vito, I know you're saying some dollars for equipment upkeep. What I would like to do is dedicate anything now in the next couple of weeks, whatever comes in, to 2 Afghan families. And the 2 families we have in mind had made it out of Afghanistan to a neighboring country, and just literally today were ejected from that country and forced to go back into Afghanistan. Now keep in mind, they're entering into a place where they're not welcome, and where the context is very difficult. They'll have to hide and try to stay under the radar. There are no jobs to speak of there now. With the folks that are in control, it makes it very difficult for them. So we're going to give anything that comes in the next couple of weeks to try to help those 2 Afghan families that'll be going back into that cauldron. They had escaped, and the country they'd escaped to just ejected them literally today. So I want to thank you guys for that and for what a difference you're making in their lives. For anybody who's pitched in, I just want to say thanks. It's a huge help to them, and it lets us be generous to them because you've been generous to us. So thank you so much. Well, you can see this NGC 4085 is starting to shape up. So let's put this here, NGC 4085, and we'll also put it down in the title, and this time I won't forget and leave you on the title too long. This is NGC 4085, a galaxy in Ursa Major. Okay, NGC 4085. While that's shaping up there a bit more, let's see if we can find that 4085 in Steve O'Meara's book on page 98. 98. Page 98, 4085. A tiny and very dim galaxy near the brighter, more obvious NGC 4088. I see. So let's do it like this. We're guessing that this object on the left, let's see if we can pump those mids up a little more, make that just a little bit brighter. This object on the left is 4085, NGC 4085 on the Herschel 400 list. And on the right there is 4088. Oh, that's our next object. We can do a 2-for-1 special here. The galaxy is a 12th magnitude speck of light, seen only with averted vision. If you see a star in the galaxy's location, you are seeing the galaxy's core. At 72, it's a slightly more apparent. Still, it's just a dot of dim light with averted vision. Larger apertures will show a thin halo extended east to west. So that's 4085. Now to help us, we're going to use SharpCap's Deep Sky Image Annotation. And it is indeed pointing out that this is 4085 and this is 4088. 4085 and 4088. You might say, well, why is that off a little bit? That's just the nature of the way the screen orients sometimes. So we're looking at two different galaxies here, 2 for 1 special. I think 48.8 is going to be a little bit better view. Look, we can see the bar here and the spirals, but with 4085, all we can see, exactly like Steve O'Meara said, is just a little thin needle here. And our colors are balanced, and we've pumped up our mids about as high as we dare go. That's just with 5 minutes of data integration. CCV will give the amount of the first 3 digits of your next observation. What? $408. That's amazing, Larry Fraley. Rats, I wish I'd gone to 4888 first. No, I'm just kidding. That's amazing, though. $408. That will help those 2 Afghan families amazingly well. Thank you so much to CCV, Christ Church of the Valley, an amazing church in Phoenix, Arizona. I'm a little bit beside myself here. Thank you so much, Larry. That's fantastic. That's fantastic. Wow, I'm just kind of pausing here for a minute to try to absorb this. Thank you so much. Here's 4088. Wow. It's a dim, diffuse glow, a little more than 1 degrees southeast of NGC 4026. It's in more remote regions of the sky. It says it's a diffuse and difficult glow, about 5 minutes diameter. Averted vision is required. Any light pollution will wipe it out. We have a lot of light pollution, but thanks to electronically assisted astronomy, it's not quite wiping it out. Even under dark skies, it remains dim and diffuse glow with a very weak central condensation. Large telescopes will enhance the galaxy's brightness and show some model texture. I think we're actually seeing a little bit better than that. On this 4088, we're actually seeing a little bit of the spiral structure and a little bit of the bar. This is a barred spiral, as you can see. And we're making out a little bit of the bar here, and that's the spiral structure around it in just 7 minutes of data integration. So that's pretty amazing. Let's see if we can bring up just a little more of the sky glow and see if that gives us a little more of the mids. $408 from CCV. Good to have you here, Westlake, from Southern Ontario. Of course, Vito, I'll have to confirm with him that he doesn't mind us using his money. He initially said it's for equipment upkeep, and that's okay if we do that. But if you would permit, Vito, we'd love to combine yours together. That would make it $428 or so, very close to $428 for those 2 Afghan families that were ejected. They were completely kicked out of the neighboring land where they had made into a refugee camp. About 3,000 people in a refugee camp there. They've now been kicked out of that camp and forced back into Afghanistan. Pier-Tech, good to have you here. So sorry if you've got some cloudy skies down there. I tell you what, 4085 here. Let's go save exactly a scene. And what we want to remember is this is also 4088. So I'm going to add here 4088, and we're going to see if it will stack. We'll see if it will name it correctly. And in our observation, we're going to say 4085 was needle-like. On our left, as we observed, the core brightened some, but very difficult. Now we got to remember this is 15 degrees above the horizon too. And then with 4088, we're going to say we could make out a lot more of the core. It looked a bit like a barred spiral. A barred spiral galaxy. Now just to check ourselves, this is NGC 4088. Before we close that, let's go out here and let's see if we can find NGC 4088 and see what we can. 4088. There we go. Yeah, look at that. That's the Herschel view. Let's get a bigger picture of that. NGC 4088 Hubble. NGC 4088. Barred spiral galaxy. Yeah, for sure. Let's go ahead and click on one of these. Maybe this one. It's not giving us a very big shot of it, is it? I was hoping we'd see a little bit more, a little bit larger view there. Here we go. So this is NGC 4088. I'm going to say here in the observation, we jumped out to a Hubble view, which was a bit more vibrant than our RASA 11-inch could provide. Haha. We could see the bar and all the star, what would you call that, nursery, where all the stars were being born. Beautiful galaxy. It's just an amazing view, isn't it? Now that removes 4088 from our list. One last time, let's take a picture of this just to save our 11 minutes of integration. And let me look one more time. Here in the stream, we've got about 17 people watching. Thank you. If you're tuning in late here, we're working on a Herschel 400 list of objects. We're getting ready to go to 40, not Hubble, it's a 2-micron all-sky survey photo. Thank you so much, Stu, for helping us out with that. This is next. Let's pull off of our imaging and go to next target. Let's go to 4026. So we'll slew to that, and we'll go to the scope cam while that slews. NGC 4026 is at about 14.9 degrees. So we'll NGC 4026. 4026, and down in our title, we'll say NGC 4026, and it's also an Ursa Major, and it's also a galaxy. So let's go back to our screen here, and we'll just plate solve one more time. Oh, Stu is asking people if you'd click the like button or thumbs up, and he's pointing out that helps other people find the stream. Very kind of you, Stu. You're exactly right. If you like content like this, please do click that thumbs up button. You could also click subscribe if you aren't already subscribed. 4/100ths of a degree off. So we're a lot more accurate now on our, so we're going to start imaging. We're a lot more, oops, we were still kicking around there. I hope that won't show up in the live stock. Let's hope by the time we capture this impression that our scope had settled. We're going to see here with the first image. If it's all blurred, then we'll stop it and start it again. I've gotten a little bit trigger happy on the last two objects and haven't waited for the scope to settle. That actually looks like it had settled, in fact. Okay, so our color balance looks good. Let's pull our black level over to about right here. And then let's zoom in on this very tiny object here in the middle. And you can see there's a very noisy frame with 20 seconds. But with each successive frame of live stacking, that noise will drop out, Lord willing. Larry, I love the way you did that when you said CCV will give the amount of the first 3 digits of the next observation. You were like playing Wheel of Fortune there. I love that. This is 4026. So we're going to look in the back here, and 4026 is on page 97 in the Stephen James O'Meara book. 4026 is a relatively faint but very concentrated lenticular galaxy, a little more than 1.5 degrees southeast of NGC 3953, and small telescopes appear as star-like at low power. Yep. So it's best to star hop the field. And then it says its tack-sharp star-like core is an easy target once you find it, and sure enough, it is. It expands to a thin 4-minute long string of dim and fuzzy light. So that's what we're going to try to find. Needle-like disk with a bright core that intensifies to a star-like nucleus. So that's 4026. 4026. So let's see if we can play with this and see just a little bit more of this object. Look, now we're starting to pick up some of that needle. Although our light pollution and our moonlit sky at 93% moon is certainly working against us. With 2 minutes of integration, we're already starting to pick up some of the needle-like nature of this galaxy, 4026. While this is live stacking for a minute, let's just sum up, for those of you who are new to the channel, what we're doing here. We have 200 feet out in the outside of the office where I'm sitting, an 11-inch RASA telescope. And that Rowe-Ackermann-Schmidt astrograph is what that acronym stands for, RASA, Rowe-Ackermann-Schmidt astrograph. That RASA telescope is unique in that it doesn't have a place for an eyepiece anywhere on the telescope. Instead, it's designed to mount a camera at the front of the scope. And the camera is riding, in our case, on an Octopi-Astro camera interface. The Octopi-Astro camera interface is connected to the corrector plate of that RASA 11. And the Octopi-Astro allows you to try to slay the dragon of things like the back focus and the tilt that happens often with a full frame, or in our case, an APS-C frame camera on the front of this RASA. It slays a little bit, gets that tilt a little more under submission, and then this APS-C format camera, it's a pretty wide format camera, like 6,400 megapixel, whatever camera. This camera is giving us pretty good live views as if it were an eyepiece. And what it does is it connects into a little outrigger unit we have, into a USB control hub. It's a Pegasus Astro USB hub. And the USB hub is the blue box that's sitting right on top the Los Mandi equipment plate that you see in this little view of that outrigger plate. The smaller blue box on top of the USB hub is a Pegasus Astro Pocket Power Box Micro that we use to power the cameras, separately from the power provided by the iOptron CEM70G mount. In the case of our mount, if we try to power the cameras through the mount, it just does not work with true USB 3 imagery that we're getting from this nice ZWO ASI2600MC Pro camera that you saw connected to the front of the scope here. By the way, on that outrigger, we also have this little red ZWO ASI178 monochrome camera, and that normally gives us a sky view. Now tonight, for some reason, when we opened up this upgraded version of OBS, we weren't able to load that sky view tonight to be able to show you that. So unfortunately, that's just the nature of sometimes when we operate on the cutting edge of these software that we're using. Now we're starting to see a little bit more of this needle-like spiral galaxy here, or lenticular galaxy, as Steve O'Meara pointed out. Let's darken the sky now just a little bit more and increase the contrast. Boy, that's the trouble when you darken the sky too much, you lose the needle-like nature of that object. But I hope and trust you can see it's just a little bit flattened out galaxy. Let's do an observation here, and this is NGC 4026 will say we could easily see the bright core, but the structure of this lenticular galaxy was tough to resolve. And the light pollution and the 93% moonlight. Still, if we strained at 6 minutes, we could still make it out. Now, I just want to point out that this is 6 minutes, and a regular astrophotographer, this is 4026. An astrophotographer would spend much longer on an object like this, NGC 4026. NGC 4026. Now there's that little, see if we can find a little bit broader, yeah, there. So you see that's the needle we've been looking at, that bright needle-like, that bright hub, and then this needle-like core here. And that's what we've been looking at here. Now, the angle of the camera is on a different angle than what this astrophotographer used, but he probably used, or she probably had this, oh, this is that all-sky Sloan Digital Sky Survey again that Stu pointed out last time. Not sure how long this exposure was, but certainly longer than what we've been on tonight. Let me see what you guys are saying here. 50 million light years away, 80,000 light years across. Too much red, Stu says. Thanks for the tech tour. Azray, the ZWO ASI2600MC Pro does not like to share its power with other stuff, at least on my setup it doesn't. You're right, Azray. We feel exactly the same way. That's why we have ended up giving it its own power rather than trying to power it through the mount. We're going to save this as seen at 8 minutes, and that's NGC 4026. And we'll now kick back into next target mode, and we'll look over here in our list, and we'll go next to NGC 3953. It is also at 15 degrees above the horizon, so we'll slew to that. Slew is just an astronomy word that means move to it. The scope didn't move a lot, did it? So let's change our title while that's settling. Let's change our title to NGC 3953. 3953, and this is also a galaxy in Ursa Major. Let's go back up to our screen and change SharpCap's title to 3953. We changed those in both places just because the main title you see at the bottom of your screen is kind of a courtesy to our viewers, so you can kind of remember what we're looking at. The title at the top of the SharpCap screen is actually the title from which SharpCap will take the title of the image when it saves the image. So that's important for us to keep all these images straight as we look at them and catalog them, and we also can patch them into the observation afterward. About 3/100 of a degree off. Now this time let's wait just a moment, and sure enough we did see the double stars there as the mount makes that tiny 3/100 of a degree correction so that we have this object centered right in the middle of the frame. And I just want to say a word about our targeting software. We've gone now to Deep Sky Planner 8, and that's a bit of a journey for us. We started out with Astro Planner and loved it, but for us the finding the observing frame and posting the pictures, it was just a little bit too much for us to manage. So we finally switched into the dream world of hoping we could use only Starry Night Pro as our targeting software and our logging software. However, after several dozens of objects there, we got tired of the fact that Starry Night Pro has a glitch. And I'll say this openly now to SimCura because I've complained about that glitch for 1 year without a fix. And the glitch is that when you start new observations, maybe 1 out of 5 times, the observations are limited to just a few characters. It's like the software gets in a loop or something and it won't let you use the full observation window. And after complaining to SimCura, we finally just said, okay, enough already. We surveyed the market again and found Deep Sky Planner 8. We like this software. The designer, vendor, has been very good to work with us on it. She's actually taking our Starry Night Pro observation database and actually converting it so that we'll be able to import all of it into Deep Sky Planner. So thank you, Phyllis, for your cooperation. Very kind of her. We hand-coded in the Herschel 400 list that we had observed in Starry Night Pro, and that at least let us get started with the Herschel 400 list. We could tell which objects that we had observed and which ones we hadn't. I'm just going to move this window a little bit more into front and center here so you can see a little bit better the way Deep Sky Planner works. Now in your screen, it's going to be a pretty small print. But up here at the top, there are a number of tabs that let us filter objects. And so what we have is we've started out with a plan of the Herschel 400 list. And even though it's a plan of just the Herschel 400 list, it is entering these observations in an overall database that's keeping track of everything we observe, even that's not a part of the Herschel 400 list. We've also said, talk to us in relation to a local horizon model, if available. And we did make a local horizon model. We took our scope very painstakingly around the horizon, 10 to 15 degrees at a time, and shot images of every place where the trees form the horizon, usually around 8 to 10 degrees above the horizon usually. And we shot that for the full 360 degrees. Deep Sky Planner made a model of that view, and it uses it to compute whether or not an object is visible. And then in this tab, we're just basically telling it, show us only the objects that are visible that we haven't observed yet from the Herschel 400 list. And we localize it and say, keep track of it for the exact time of right now at our local location, and takes all that in consideration when it prepares this list of objects for us. So we're liking this a lot. We can click the Add Observation without having to go to a different tab, and I like that. With Astro Planner, you kind of have to mess around with several tabs, and the Notes window just works. It doesn't have a glitch in it. I like that. So here we started this observation in this case, NGC 3953. I'm going to see if I can move this window, and sure enough, it lets me. It lets me move the forward. I wonder if I cancel out of that. Yeah, it keeps. I'm going to move this window out of our view now, a little bit off the side, so it doesn't get in the way of our live stack. I'm going to try to close in a little bit better on this view. I wonder if we move this over here, show a little bit more of the sky view. Boy, whoever said too much red, was that you, Stu? That is a lot of red, isn't it? Yeah, we're going to bring the red down manually because I think you're right. Boy, it does not like it when we do that, but we're going to do it anyway. I'm going to bring the reds down. Look how it messes up the model of the color balance when we move those reds. I think this red is it's a byproduct of a lot of light pollution and maybe perhaps even some of the horizon, because this is now just 15 degrees above. Let me click run. So we're on 3953 and get up. It's 11 degrees above. So we're down almost in the trees here. Let me just put up with the red for a minute. And let's see if we can fish out a little bit better view of that structure. Boy, it's very tough, isn't it? Very tough. If we darken the sky, then we lose the structure. So we need to float right in between and balance the light pollution and the structure of the galaxy. This is why they call it the 301 level, the Herschel 400 being a lot tougher observing challenge. You got to have at least, you know, Steve O'Meara did use a 4-inch scope, but he's an extremely gifted observer visually. Most people say a 6-inch scope. And then you have to have extremely dark skies and no moonlight. Let's just look real quick. We're at 6 minutes. Let's look real quick, 3953, and see what Steve O'Meara says about this. 3953 is on page 96. 96. He says, it's a barred spiral. Huh. And he says, you see a circular glow. Yeah, that's exactly what we're seeing. And it transforms in time into an oblong disk. The core is visible, but the rest of it is just mottled, elongated disk. Thin, anemic arms may waver in and out of view. Thin, anemic arms. That's a pretty good description of what we're seeing here. So we're just going to say, let me see what you guys are seeing. Supermassive black hole in that last object. Stu says there are 50 galaxies in this group. How many are we seeing tonight? Does the moon move too fast to get a high-res picture in the RASA? No, we can get a nice high-res picture of the 93% bright moonlight. Dark Meta, good to have you here again tonight. Stu, does it compute the best observation time? No, we have to compute that observation time by hand. Can it tell you when to observe things when they're at their best? I see what you're asking. Yes, Deep Sky Planner does have a best column, and it does compute that. So it's all in its own column. Let's see, we're going to say this spiral galaxy might barely be showing us a bar at 125% of our 2600MC Pro's capabilities. So we're into the digital zoom here. We couldn't make out much of the arm structure, however, at just 13 degrees above the horizon with a 93% moon. So you might be asking, well, why do this? Why do this observing when the moon is at 93%? Why don't we just skip the night? Well, it's just because with electronically assisted astronomy, at least we're seeing these objects. And if you use your imagination, you might even be able to make out that bar. You can barely see that bar. So I get a kick out of just kind of defying the odds here. That's why we do it on a night like tonight. I'll just show you, let me bring this window over very quickly and show you the best column is the one that we're using right here as our guide as to which object to go to next. So we are using the column that shows us what's the best object of the objects that you have. And at 17 degrees, it's showing us the next object. So let's move to that right now. Next target is NGC 2976. 2976. and it's only 17 degrees above the horizon. So keep in mind, an astrophotographer would probably set his or her software only to show things that were 30 degrees and up, just to get rid of the night sky view from the neighboring city, you know, the light pollution, and also to get rid of the extra atmospheres that we're looking through. You might remember that as well. We're looking through a lot more rarefied air in the Earth's atmosphere when we look through the sides of our atmosphere than when we look straight up. It's the thinnest when we look straight up. So these are observing challenges, but I almost like that idea, you know, because I think it's the way we ought to look at things as electronically assisted astronomers. We ought to be willing to take on the odds, because our equipment, we want to develop the muscle memory to stretch our equipment to see the best we can see in any given night when the clouds allow. And sure enough, we do at least have a clear sky tonight. We were 1800ths degree off in this slew, so I did go ahead and do a plate solve, and it's making the correction now of those 1800s. So you'll see in a minute, perhaps the double stars. I think we might be settled in now. So we'll go ahead and now and start live stacking. Part of the wonder of electronically assisted astronomy is this concept of live stacking. You take a picture that's 20 seconds long at 200 gain, and then you hold it in the RAM of your laptop. You take another 20-second picture, 200 ISO, 200 gain. You stack it on top of the first one. The software notices that a lot of the grain in the images changed between images. Anywhere where there's grain, and you guys that are photographers, you know that word. It's basically just the scratchy looking, looks like confetti or just amp glow or light glow. It drops out all that grain from the image that it can, and it concentrates instead on the specks of light that didn't change between images. And it reasons those must be the stars. Those are the things that he wants to see. And by averaging all of the light between those images, SharpCap, which is the imaging software we're using here, allows us to be able to see a lot more than we could have seen with just our naked eye. Keep in mind that our naked eye does no live stacking at all. Every single 30th of a second, our eye snaps another picture. Now, thankfully, God gave us amazing eyes. And with a 30th of a second, we can see a lot. But boy, with this astro-specific camera that's cooled down to 8 degrees centigrade below zero, the sensor is amazing on these astro cameras now. Taking a 20-second time exposure and adding it together with others, we can see things the eye would never be able to see. And that's why in this light pollution, with 93% moonlight, we're picking things out that really are otherwise impossible through an eyepiece. Only with the help of electronically assisted astronomy are we able to do this. So that's kind of why I like the challenge of a 93% moon and Bortle 5, Bortle 6 skies. A Bortle rating is a measure of the light pollution. We are using a filter. It's the Celestron light pollution filter that's designed and made specifically for the RASA 11. So it's a big 2-inch filter, very expensive filter as filters go. I think it's about $600. That filter alone gets rid of a lot of Louisville light pollution and some of the modeling that we're getting from the moon, not all of it. You can see here as a little, in the middle of the screen, there's this little fuzzy patch. And that's the galaxy that we're looking at here. This is NGC 2976. NGC 2976, and it's also a galaxy in Ursa Major. So while that's live stacking, we're at about 3 minutes. Let's go look and see what Steve O'Meara says and see what you guys are saying. Dennis says, it's the challenge. That's why we do it. Laugh out loud. Stu says, how is this different from Lucky Imaging? I think Lucky Imaging uses a video, and when you're done capturing a video, when you post-process, you pick out individual frames from the video that made the planet look pretty good. But that's usually used with a brighter object like a planet that's sizzling in the nighttime sky, and you're just looking for an image that came out pretty good in the diffraction of the nighttime sky. These are time exposures, so it's not Lucky Imaging really. And I hope we're back to the screen now. Yes, aha, fixed. Okay, so we're at 2976. 2976. 2976 is on page 40. And I might just remind us that we're actually looking a little bit far into the future. This is January's object, but I enjoy a challenge. This object is only 17 degrees above the horizon. Let's in fact do exactly 17 degrees above the horizon. And I like that idea that we can observe an object that's just 17 degrees above our horizon. 2976. It's a member of the M81 group of galaxies, dim ellipse of light, best viewed under a dark sky. You'll need to take your time to find this. Everything's rather dim. It's a faint ellipse of diffuse light. That's what we're seeing. It almost vanishes with increased magnification, and that's what we're observing here. It almost vanishes. Larger scopes will reveal a mottled texture to the galaxy, and there's still no distinct central condensation. And I would agree, that's exactly what we're seeing here. Let's bring our mids up and see if we can't force this to get a little bit brighter and make it appear before your very eyes. There you go. That's NGC 2976. It's the first time I've ever seen it, and I trust that for some of you, it might be the first time you've ever seen it as well. We were amazed, frankly, that at just 17 degrees above the horizon, I wonder, yeah, 93% moon. I wonder if this will tell me, because in a lot of our observations, it actually tells you how many air masses you're looking through. 3.4 air masses. We're looking through 3.4 air masses compared to what we would get if we were to image this straight up. 17 degrees above the horizon at 3.4 air masses with a 93% moon and a lot of Louisville light pollution. We could still see this mottled, dim, fuzzy galaxy splotch. Steve O'Meara pointed out there is no central core, no bright central core, something like that. Okay, we're going to save this exactly scene. I love this. It's almost like a ghostly glow, isn't it? A ghostly glow. If you add it to your watch list, you'll forget to observe it in January. Yeah, that's exactly right. Okay, let's switch back now to next target. And we're about halfway through our observing list tonight. again, looking at this in order of what would be the best to view next. We have a 22-degree object that's called NGC 1961. So let's go there next. We're going to slew to 1961. 1961. NGC 1961. NGC 1961. NGC 1961. It's a galaxy in Camelopardia. How do you spell that? Constellation. Camelopardalis. Camelopardalis. It's Dalis, not Dilis. Camelopardalis. Okay, so there you go. Camelopardalis. Camelopardalis is, you know what you can also do with Deep Sky Planner, I forgot to mention this. You can say show chart. I want to bring this over so you can watch this happen. Notice that we're on NGC 1961 here. I'm going to right click. I'm going to say show chart. It immediately queues up our Starry Night Pro to NGC 1961. So I think that's pretty amazing that it works in harmony with whatever planetarium software that you want to use. And that's just right-click, show chart. That's all you have to do. And it also does the slew to and the syncing, just with a right-click. So I'm really liking Deep Sky Planner 8, and I think it's a great solution for me, but you've got to decide what's good for your workflow. Let's go back to our live view here and start stacking now that this has settled down. There goes a nice satellite photobombing across our frame. We could go figure out what that is, but let's focus on the Herschel 400 list tonight. I have tried to chase those satellites before. And what you have to do is, use your planetarium software to see what was the satellite that just crossed the view here. It's a little bit more than I want to do for right now when we're trying to focus on the Herschel 400 list. Let me see what you guys are saying. Amazing photo on Wikipedia. Now I wonder, Stu, was that an amazing photo of 1961 or of the splotch that we just saw? Which was it? This is 1961. We're going to do a new color balance. Bring our blacks over to the crest, maybe right below the crest. And then we're going to zoom in here. And pump up our mids a little bit. The splotch. Remind me, if you wouldn't mind, Stu, what was that splotch? Let's go look at the photo you're talking about. Was it NGC 39 something? 2976, thank you. Boy, Stu, that's very helpful. 2976, and we'll say Wicca. Oh, you're right, that is amazing. Oh my goodness, look at that. Wow. This is based on Hubble Legacy Archive data. I'm just spellbound by this. It looks like hundreds of thousands of stars. Still not much of a bright core. Even in the Hubble, you might see just barely a bright core right in the middle, right there, if you strain. Barely a bright core, but really not much of one. Look at these cool diffraction spikes. Wow. Boy, Stu, thank you so much for pointing that out to us. That was well worth it. Okay, so we're looking here at NGC 1961. We're at about 2 minutes. Let's go see what Steve O'Meara says about 1961. Yeah, we did zoom in, huh? That is. Thanks for pointing that out to us, Stu. 1961 is on Steve O'Meara's page 36. So once again, we're back here in these January. Yeah, Stu says he wowed as well. It was a beautiful image. 1961. It's a very faint mixed spiral galaxy. What's a mixed spiral galaxy? About 5 degrees northeast of 4th magnitude Alpha Camelopardalis. Extremely difficult to see in small scopes, even under dark skies. You have to know where to look. He says, I could not see the galaxy in my 4-inch at 23 power. It's dimly visible at 101 power. Has a tiny core, 2 arc-minutes wide of dim light, surrounded by a 2 arc-minute wide halo of hyperfine light. Concentrate on the object's location, use averted vision, which you call the galaxy's small core to blossom a bit into a faint glow. Take your time and breathe rhythmically. Steve O'Meara makes a lot out of breath. In fact, I think I remember a story that he actually used oxygen in an oxygen tank to be able to bring in Halley's Comet the night that he observed it, and was the first human to recapture Halley's Comet in our modern time when it came back, I forget what year. That was Steve O'Meara who did that. So he's quite an accomplished observer. And he says, breathe rhythmically to be able to see this. Just want to point out the other alternative. If you don't want to use averted vision, which means looking in the corner of your eye for an object. If you don't want to use averted vision and you don't want to have to worry about how you breathe, just use EAA, Electronically-assisted Astronomy. Dark Meta asks us, would you please do a show on aliens soon, please? Dark Meta, we'll have to plan that out. Kimberly, it was very beautiful. I'm sure you're talking about the NGC 2976. This object, I don't know if I classify this as beautiful. What do you guys think? But it is a bit of a treasure hunt. It's a scavenger hunt to be able to see it, isn't it? NGC 1961, and let's add observation. We're looking through 2.6 air masses. It's just at an altitude of 22 degrees right now. This dimly lit mixed spiral, and I'll credit O'Meara in parentheses here because he was the one who told us that. Whatever a mixed spiral is just 2 arc-minutes of extent wide with a 2 arc-minute wide glow. Halley's Comet was 1986. I saw it at Christchurch Observatory. Didn't need to squint. That's awesome. That's awesome. Well, you were watching the comet that Steve O'Meara was the first to recapture visually when he saw it. That was at an observatory at Cambridge in Boston. I think, if I remember right. Maybe I'm wrong on that. spot. But it was a great story. Used oxygen to be able to see it again. Very dim, but visible. This is fascinating. To bring this in, let's go out and look for NGC 1961 Hubble. This is indeed the Hubble. Wow, what a swirl, right? Man, look at all this. Look at this arm here that's scattered. It looks like it's been interacted with another nearby galaxy. And it's gotten all mixed up, hasn't it? Look at these stellar nurseries here. And that super bright core that probably has a supermassive black hole. Beautiful. Thank you, Hubble. And here's RASA. A little bit different. But you know, we can start to see the arms, can't we? And a little bit of a dust trail right here. I'm loving it. The fact that we can see it at all in the suburbs of Louisville, Kentucky is just, to me, an amazing thing. Mount Lemmon photo is better. NGC 1961 Mount Lemmon. Wow, you're right. Can I make that bigger? What about Control Shift Plus? Yeah. Wow. Now this is a lot. Boy, it got smaller, didn't it? There we go. This is a lot easier to see this interacting arm here. Some galaxy skated by it and messed it all up with the tidal forces. Beautiful. Thank you, Stu. That is true. It's beautiful. Those colors, right? All the blues, golds, supermassive black hole, middle. Amazing. Okay, goodbye NGC 1961. It was a good year. Let's go to next target. And again, we're looking at the best column. Looks like NGC 1502 is an open cluster. So we'll slew to it. And it's at 24 degrees above the horizon. So notice our RASA there is shifting a little bit. The weights are a little bit more down, just with the way it could find it. And change our name. Oh yeah, this is neat. NGC 1502 and NGC 1502 and open cluster in Camelopardalis. Camelopardalis. Hope I spelled that right this time. Well, there it is. There she blows. No sense in doing a plate solve. I mean, that's the cluster right there. We could just stack it for just a moment and see if there's any nebulosity here. It's a cool little open cluster, isn't it? Very bright. 1502. 1502, page 35. It's another January object that we're observing early in September, way down on the horizon. 1502, bright open star cluster is just visible to the unaided eye under a dark sky. Wow. Easily seen in binoculars. And it's at the southeastern end of a beautiful asterism known as Kimball's Cascade. Huh. It's 20 arc minutes across, core is very tight. 4 of the cluster's stars are immediately obvious in small binoculars. We can imagine which ones, can't we? It's a wonderful sight in telescopes of all sizes. It's a tight ball of sun surrounded by a coarse sprinkling of outliers. Brilliant 7th magnitude double star, Struve 485. Let's zoom in on this now. Wow. It's beautiful, isn't it? Pull that black level over to about right there. Pull up the mids to about there so we can see if there's any nebulosity in this thing. A brilliant 7th magnitude double star, Struve 45, shines like finely cut topaz near the cluster's center. Finely cut topaz. Can you see it? More than a dozen suns, many in pairs, surround NGC 1502's tight core. The brightest members form a lazy X shape. You know, I think I can see it. Here's one of the axes of the X, and here's the other axis of the X. A lazy X shape centered on Struve 485. 60 members with larger telescopes, be prepared for an even more outstanding display. STRUVE, Struve 485. So in our observation we'll say O'Meara observes a lazy X shape centered on Struve 485, the double star right in the middle of the X. Around 60 members, many doubles. Gorgeous, tight in the middle, outliers add to the fun. Now it's interesting, isn't it, that this is not on the Messier list, even though it's barely visible as a naked eye object. It is also not on the Caldwell list, surprisingly, but it is listed as Colander 45. So we'll save exactly a scene. And just a beautiful cluster, isn't it? Boy, these colors are so messed up on bright moonlit nights. It's just almost impossible to get it all worked out, isn't it? Dark Meta is waxing philosophical here about statistical anomalies and heavy stuff. You know, we can go to 1501, a planetary nebula. It's at 24 degrees. It was probably, oh, I think I see it right there. Look at that. It's just barely a splotch here. How fun is this? Alpha Camelopardalis in the constellation was suggested as a candidate runaway star that had been ejected from the cluster NGC 1502. Huh. Incognito Astronomer just came in and had the same problem with getting colors correct. Well, I'm glad, Incognito Astronomer, because 93% moon and the strange light dome of Louisville kind of mess us up here. Boy, talk about color balancing issues. Look at that. Let's see if we can do a better job color balancing here. Let's bring the reds down just a hair, but not too much. I think that's just right there. Let's bring this sky glow in just a little bit more because the planetary nebula will have part of the sky glow. Let's bring the mids up a little to brighten that object. Wow, that's a cool planetary nebula, isn't it? Right here. Take a look at that. You can easily see the little whatever white dwarf thing there is that's in the middle of this planetary nebula. This is better than many of the planetary nebulae that are on the Caldwell list. And I dare say it's as good as maybe one or two. I don't know. It's as good as any of the Messier planetary nebulae, but it sure is better than some of the planetary nebulae in the Caldwell list. This is beautiful. Now, I'm going to go ahead and zoom in digitally just so you can see some more of the structure. Even though the image will start to pixelate, I love it that you can see that structure so clearly. This is NGC 1501. NGC 1501. NGC 1501, a planetary nebula in Camelopardalis. Wow! Tell you what, this is worth the price of admission. This is worth every bit of what you paid. 15, of course some of you paid more than others. Thank you, Larry. Thank you, Vito. 1501, page 35, in Steve O'Meara's book on the Herschel 400 list, popularly known as the Oyster Nebula. NGC 1501 is a bright planetary nebula that's easy to see in small apertures. It's a slightly fainter and a little smaller than the more famous planetary nebula M76 and Perseus. Under a very dark sky, you can see it in binoculars if you know where to look. In a telescope, it looks like a conspicuous 11th magnitude star, a 2-inch. With a 4-inch, it looks like an 11th magnitude star in a rich star field. You'll miss it when you sweep the star field, but use the chart. It's a very faint mixed spiral. What? Oh, sorry. Let's get back to here. 1501 is, if you use chart A, you'll see it. Perusal area, it's a tad swollen and fuzzy, not stellar. At 101, it immediately reveals itself as a glorious orb of dense light, even with direct vision. Fainter stars can be seen around the nebula. With a vertical vision, a faint annulus can be seen quite readily. That would be like this ring structure. At higher power, it looks like the ring nebula. At low power, in larger telescopes, the nebula is a glorious sight, displaying a sharply defined ring at high power, and we can see the central star. Now, it's probably worth repeating what a planetary nebula is, isn't it? Wow, this is a glorious object. One of the best we've seen, I bet, right? In the Herschel 400 list. bright green ring with, I'm starting to see some other tones there. I'm going to guess those are red. Reddened tones and a bright central star lighting up the entire firework at 175%, and 5 minutes. It was glorious. NGC 1501. So once again, a planetary nebula is a case of like a red giant type star, for instance, that towards the end of its life kind of begins to run out of steam, and it finally just sort of waffles out its outer layers, and those gases and dust and fuel that it just sort of ejects out, it goes out sometimes at light speed, sometimes at slower speeds, but those outer layers eject, and then the central star recollapses and starts back up again as a white dwarf now in its second life. Now as a white dwarf, it acts like a neon sign, illuminating and backlighting that material and ionizing it, often with hydrogen and oxygen mixtures. So we get green from the oxygen and red from the hydrogen, and that's what we're seeing here. We're seeing that envelope that got ejected out, and it's just beautiful, isn't it? So this is the way it looked, whatever distance it is. Stu, are you seeing a distance on this? Yeah, nothing to do with the planet. It's very brain-like in the Hubble. Let's go look at that real quick. This is NGC 1501. NGC 1501. Wow. Oh my goodness. Now see, I would not have picked up on the fact that it's irregular. I see what you mean, Stu, about it being brain-like. And you're right, Stu, nothing to do with the planet. Dennis pointed that out first. In Stellarium, it looks sort of like a brain. What if you bump the gain to 230-second subs to see if it helps? I don't have a calibration frame, I don't think, at 30 seconds. I might have, but I think, but let's try it. 30 seconds, just because you asked. 30 seconds. There was an instant change there, wasn't there? I might actually, come to think of it, I might have shot a calibration frame, you know, a dark frame at 30 seconds. I might have. Let's do another color balance and move our darks over to here or so, and then move our mids up to here, and then let's bring the reds down a couple of notches so the green takes charge again. It's beautiful, there's no doubt. At any observation, it's beautiful. At any exposure length. Like the Crab Nebula, right, Azrae? Quite a bit of sky glow there. There we go, get rid of that sky glow. Isn't it kind of like painting a picture, messing with a histogram? Okay, save exactly as seen. What a beautiful object. Thank you, Lord, for making NGC 1501. Wow. Well, the next object here is in the best column at least, at 15 degrees above the horizon, is NGC 1545. NGC 1545, a little bit of scope movement there. NGC 1545. NGC 1545, and it is an open cluster in, is that Perseus? An open cluster in, must be Perseus. Oh, it's in the trees, unfortunately. I wondered what was going on. So that one is not visible for us. It's probably just getting ready to go off the image there. Let's try NGC 1528. You know, this is a specific tree, and I need to shoot that tree specifically. I knew when I shot this, oh, there it is. Yeah, we'll just do a quick, this one will go behind the tree very shortly, I bet. NGC 1528. And it's also an open cluster in Perseus. We'll do a quick plate solve here so we can use deep sky annotation to make sure we're looking at the right cluster. This is at 17 degrees above the horizon. You can see this tree here in part of the frame. Yeah, 0.46 degree correction. So we're gonna, I bet we're gonna scoot over and center that NGC 1528. You can see how the screen gets all these jaggies real quick from that scope movement on the synchronization. This is 1528. Let's just save a snapshot of this. And our title slide needs to change. 1528. But it's still an open cluster in Perseus. 1528. Let's just see real quick what Stephen James O'Meara writes about it. 1528. 328. This is a December object. 1528. Shines at magnitude 6, a decent naked eye object, a decent naked eye challenge for anyone under dark skies. Fine object under binoculars. Its brightest members will start to appear to the dedicated observer in even the smallest pair of binoculars. It's a well-resolved suns of scintillating in front of a fuzzy backdrop of fainter stars. The brightest ones are curved in rows. Yeah, see the curved rows or waves. See if you can see what O'Meara is saying here. The brightest ones are curved in rows or waves. The brightest stars form a teardrop-shaped asterism. Not sure I see that. That is elongated along a northwest to southeast axis. Teardrop. Its narrow tip points to the southeast. Anybody see the teardrop? Dennis, good to have you here, brother. A dark U-shaped bay, now I see that, can be seen at the cluster's west end. Outlined by 7 bright stars. That one's visible. That U can also be extended a bit further to southwest, making the asteroid look like a sickle of Leo. Boy, how does he get all this? It comprises a healthy dose of mini asterisms, all of which look hazy at low power but resolve into distinct geometrical patterns. 165 stars of 9th magnitude and fainter. 165 stars. 1528. 165 stars. Lots of asterisms. Parentheses, O'Meara. U-shaped core. Nice cluster, huh? Beautiful. Let's see. 1444. Let's go grab it real quick. 1444. Our scope put, weights down a little bit more now. You saw it's in a configuration of weights down, the weights being over there on the left. Let's go back out to full screen and plate solve this. This is an open cluster, also in Perseus. Wonder which one it is. Open clusters are beautiful in their own right, but they are a different kind of target, aren't they? I mean, especially this one. Look how open the word open is meaning. We're only 900th degree off, so where is this cluster? We're centering it. Let's use the deep sky image annotation. What? How is that an open cluster? I think it's like right here. I bet that's it. Like I say, clusters are a little bit more difficult. Let's stack this one just a little bit, just to make sure we're enjoying all of it while we go see what O'Meara says about it. This is NGC 1444. NGC 1444. NGC 1444. What a mess, right? What a moonlit light pollution mess. 1444, 329. Small and curious open cluster. Is dominated by a 7th magnitude star. We're seeing that. Through a telescope, the star seems to occult a scattering of fainter cluster members. Your main goal is to get the 7th magnitude sun in your telescope. Well, we got that with no problem. 23 power, 7th magnitude star abutting a curious milky haze, which with averted vision begins to resolve into patches of dim starlight. At 72 power, the cluster is an insignificant agglomeration of about a dozen suns, some in pairs. The cluster has nearly 60 members, so it's better appreciated in large telescopes. Well, praise God. So 60 members. Praise God, that's what we've got here tonight. But boy, do we have light pollution, don't we? And moonlight. So we're just going to say here, O'Meara calls this a curious cluster, and we would agree. When we looked at full frame, it wasn't even obvious. Upon zooming to 95% at 2 minutes of exposure, however, we could make out the 60 members with no problem. The bright 7th mag star is like a beacon. "60-second pop." Boy, I don't know if we need 60 seconds on this, Azray. I think we've got enough, don't we? All of these stars are what are the 60 members, I think. Here in the middle. So I think we're good. Let's save this observation. And wow, we've got plenty of objects to look at. I was afraid that things would disappear. But we have plenty of things left. What do you guys want to see? I'll tell you what, let's go to this thing called the Cetus bubble. Just for fun. The Cetus bubble. NGC 246. NGC 246. NGC 246, a planetary nebula in Cetus. Parentheses. The Cetus bubble. Whoops, we were still live stacking. Sorry about that. I wonder if we save this. Look at that moonlight, my goodness. Let's do a plate saw because we did slew. Where did we slew? Oh yeah, we're way over into the northeast now. See how with our scope cam looking from behind the scope as we view the North Star. If the telescope is oriented to the right, then we're looking into the east. So this is an easterly view. We were about 0.97 degrees off, so I'm glad we plate solved. The Skull Nebula. The Cetus bubble is also called the Skull Nebula? How interesting. Let's go back out to full frame. And we should be centered now. So let's start live stacking. No skull visible. Also known as the Pac-Man Nebula. Stu, thank you for all the times you help us. These are helpful facts and characteristics. Wow, I think I might barely see a splotch there in the middle, but look at this moonlight. about that? Look at that. How interesting, after just 40 seconds. That's so hard to believe. NGC 246, otherwise known as the Cetus bubble, or the Pac-Man Nebula, or the Skull Nebula, Stu said, became visible after just 20 seconds. At 40 seconds, we could see a preview of its shape. In spite of 93% moonlight. EAA rocks. Thanks for telling us what direction is north. Azray, that's nice of you to say. Now, let's pump up these mids a little bit more. I wonder if I'm going to hold the shift key down and just creep a little bit over to the right and try to reduce the sky glow a little. So this nebula will contrast, hopefully more, against a darker sky. Boy, it just makes it ugly. Let's leave it right there for now. Pump up the mids again. Something down here. What is that? Looks like a spiral viewed face on, or I'll say globular cluster. Let's go over to our, I'll save this to my clipboard. Hit cancel so this doesn't disappear, and we're going to say show chart, and then go over to Starry Night Pro. It's pretty amazing, isn't it, the way it cues it up just instantly. So there's the Pac-Man Nebula, or the Cetus bubble. And what is the NGC 255? NGC 255. Let's try to find out what that is. NGC 255 is a spiral galaxy. Not much about it. Looks like it's the distance isn't given, but NGC 255. Now let's go back to this observation and paste that back in and say, we could also see NGC 255 off to our left in the RASA's frame. Let's go back to the real-time image now and see, here's NGC 255 right here. And here's this NGC 246, the Cetus bubble. This object would be deserving of more integration time, wouldn't it? We're at 5 minutes, so I'm going to say at 5 minutes we could see the planetary, but it was very faint still. Needs more time. Okay, the last thing I'd like for us to do is go look at the edge of the moon, because somebody asked. Moon. Now, I don't know exactly how to do that. I tell you what, let's do. Let's link the scope with our planetarium software. And let's find an object right here. Maybe right here. What we want to do here is show, what do you call this? Markers and outlines, I think they call it. And we want to try to find that's altogether too many. Let's zoom in and find some feature down here. That doesn't work, does it? So let's just go to it. Slew to the moon. And let's change our time to about 0.5. Maybe 20 milliseconds. I have no idea. 20 milliseconds. And let's change our ISO to 100. And let's see where our scope is. Still moving there. Let's see. Pac-Man Nebula is in Cassiopeia. Huh. Galaxy was discovered by Herschel. Wiki says it's 60 million light years away. That's far. Among some amateur astronomers, NGC 246 is known as the Pac-Man Nebula because of the arrangement of its central stars surrounding star field. Just quoting Wikipedia. Azray. Okay, everything has several names. Stu. Yes, NGC 281 is the Pac-Man Nebula. Okay. Let's go back to the screen and look at auto. There's the moon. So let's do a plate solve. It won't let us, will it? How about if we just, instead of plate solving, we could use the directional arrows here, which I don't use very often. Let's cancel that. There's no sense in plate solving this. Now I think if I hit right, it's going to go in the wrong direction. Yes, I need to hit this down arrow to make it go to the right, I think. Yeah. And that's because our RASA, I think you can see, is tipped over on its side in the equatorial mount with the weights up. So I kind of had an inkling of which arrow to use, but that's just based on muscle memory, or whatever you want to call it. Now let's try to use this now. And Now let's zoom in. What we want to do is zoom in on where there are features to look at. And then we want to decrease our time. 10 milliseconds. Or 5 milliseconds. Or 2 milliseconds. And see, that lets us see these features here on the edge of the moon. These craters. Isn't that cool? Let's do a snapshot of that. And we can also zoom out a little. And do a snapshot of it here. Whoops, we're saving that under the name of NGC 246 Moon. Let's change our title to The Moon, La Luna. And let's do a snapshot again so it'll save it under the right name. So there's the moon. That's what we're going to finish with tonight, gang. It's a beautiful image, and I hope tonight you grew not to dislike it in spite of the fact that it was working against us. It illuminated a lot of our targets, but using electronically assisted astronomy, we were still able to work in spite of it. And thanks for joining us. Thanks to Vito, who gave that near $20 gift. That was special. And then thanks also to Larry and the folks at CCV, who said since we were giving this to two Afghan families, they would match the first 3 digits of the next target. It ended up being $408. So tonight's live stream produced $428 for these 2 Afghan families that were kicked out of their neighboring land and pushed back into Afghanistan to try to survive. Thank you for that. And YouTube will send us that. It might take them just a little while, but we did receive a word that they had sent the first gift, which was like $463, and that's going to go to 2 families in Ukraine who are behind the war zone. And I just want to say thanks to you. Thanks to God for making all these amazing images. Really, He's the one that we ought to thank the most. And thanks to you for sticking with us. Azray and everybody, let's see. Azray said, looks great. Thank you, Azray. Thank you, Incognito Astronomer. Stu, we should come back in January. You're right, they'll look better in January. God bless you guys. Thanks to the dozen or so who are still with us, even though it's late. Have a good evening. Good night from the outskirts of Louisville, Kentucky. Emerald Hill skies. We'll see you next time that there's a clear night, and we'll look forward to then. God bless and good night.